a whole house water descaler that uses electronic techniques around the pipe to actually descale the water in the pipe. It stops the scales settling out and sticking to the walls of the pipe, etc. And this was generously sent to me by Mark, who had this in his old house. And when he was going to his new house, he took it with him to install and then thought, I kind of want to see what's in this first. So he sent it to me. And the idea of this unit is that it's got a 12 volt AC supply going in from a little plug-in adapter. And you've got 2 wires that it comes with, and you're supposed to put at least 12 turns around a pipe. So if you've got the main pipe coming into the house, or they can say you can protect just a bit of pipe within the house. Say, for instance, you've got a water heater that's prone to scaling up. You can get the copper pipe going into that, and you wrap 2 antennas around it, roughly about a foot apart. I haven't actually checked that bit in the manual, but basically 2 antennas spaced just a bit apart on the pipe. And there's only one wire to each. I notice there's other versions that have 2 wires going to each, as if it's maybe inductively coupling. And these can be apparently used on metal or plastic pipe. And the only thing they say is you shouldn't use it on lead pipe, but then that's included in sort of the usual suite of rules about, home plumbing regulations, things like that. Oh, I should mention, it's got this fabulous little red LED that scans across like it's doing something really exciting. It doesn't seem to change when you do couple these in a bit of pipe or anything. It just seems to always just run. And they do mention in the manual that it's the sort of basically a power active. It's to show it's doing things. Excellent. Shall we open it? Because I'd really like to see how this works, what it does. It's not a new thing. They've been around for a very, very long time. The case is quite smart. I like the fact it's got the logo moulded into it. That is very smart. And these are unfortunately sort of things you tend to get sales-motivated heating companies. I can think of one particular big British company that offers fixed price boiler servicing, and as one of the things they do is the people who have been given minimal training just to achieve the purpose come out, they try and pressurize you into buying these things that will improve your plumbing. Well, that's when they're trying not to pressurize you to buy a new boiler. Ooh. So what do we have here? It's a bit cramped in there. It's not going to be so easy to open up. We've got the one wire going out to the standard jack sockets that you'd expect. This should I say the banana sockets. We've got the DC connector coming in. Quite an interesting way of mounting it, actually. The connector is they've mounted pillars and then put screws down to actually trap it in place. That works quite well. There's the LED display. Let's can I get this? Let's take some screws out. So the LED display itself just has one resistor. Does it have a chip behind it? No, it's not. I guess they're multiplex because it does appear to be running them all. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many wires do we have going in? 7. So that could either be, let's see, if it was a matrix, it would be 3 by 4. Or it could be polarity reversal. Not really sure. How many are connected together? Oh, quite a lot of them connect. I get the feeling it may be polarity reversal it's using. Not sure. Maybe take a wee look at that afterwards. Let's unplug it. Polarity reversal, where it runs the 6 outputs along positive first of all, the common is negative, and then swaps the polarity and does the same again. It just keeps the number of wires down. Is there anything under this? Let's see if there's any more circuitry hiding out of sight. Given how long these have been about, unless they've upgraded it, I'm not convinced there will be much in the way of surface mount circuitry. But I'm kind of, what I was hoping for when I opened it was inductors and stuff like that to show it's kind of, or big capacitors to show it's really trying to hammer a bit of current through the pipe to actually do something. No. Nice case. Oh, it's got a seal. That's quite neat. They've put a lot of thought into the case here. So, yeah, what have we got? Will I go and reverse engineer this to save time? The chip in it. Part of me wonders, is it is chasing the LEDs. I'd guess it might be using a little microcontroller for that. Where's my magnifying glass? SH69P P20C. Not familiar with that. I'd guess this is a 7805. It is a 7805. So initially looking at it, we've got the AC coming in here. Oh, they've actually got the facility for a transformer. Right, you know what? Tell you, before I go any further, I shall go and reverse engineer this so we can take a closer look. Okay, that took a while. Rightio, I've had the scope out and everything. So this, if you want to try a bit of reverse engineering yourself, you can take a little snapshot of this and then relate it to this, which is the main circuit board, and is upside down because I just happened to reverse engineer it upside down because it felt better with the circuitry at the left for no other good reason. So the unit has the facility to have a transformer on board. They've used an external power supply maybe to make it more compatible. It gets rid of some regulations about internal power supplies. It also probably just lets them put all the liability from the main side on the manufacturers of the power supply. What is that brand? The power supply it came with is a made in Taiwan AC adapter. 12 volt, 200 milliamp. But they've got the facility for the main side. One interesting note there is, keep in mind, transformer, fuse, metal oxide varistor type sort of device, suppressed device, and then the connector. So if they'd gone for the mains powered one, very simple, you've got the connector coming in, one connection, presumably neutral, goes straight down to the transformer and also to one end of that metal oxide varistor. The other connection goes down through this fuse and then to the other side of the transformer and also to the other end of the metal oxide varistor. Very simple. Just the whole unit is textbook design. It's just very classic design. The only odd thing about transformer is the pins on the other side. Normally, on a transformer, you'd have different pinnings so the transformer can't be accidentally turned around during manufacture. So it would make sense to have a couple of pins in the middle, or the 4 pins that's sometimes used with dual windings, but you couldn't really use the double winding here because it would just short them both out. Normally, on a traditional transformer, you'd have, with 2 secondary windings, you'd have one between these 2 pins and one between these 2 pins. You'd either connect them in series with the connections come off either end, or bridge them across in parallel for higher current, lower voltage. What else is there worth mentioning here? The diodes. Let's switch back to the other side now. Here's the diodes, here's a microcontroller, here's the connector. Let's jump back to this because it's easier probably to follow on the drawing itself. We've got a full bridge rectifier here, electrobeam style, which takes the AC in that they're just jumping in these blue leads and converts it to DC. We've got a big smoothing capacitor with a decoupling capacitor, and then we've got a voltage regulator here that then converts it down to 5 volts. It is a 7805. There's something about this circuit that just makes it look like it's quite an old circuit that they've never needed to update it, so they never have, which makes perfect sense as well. The 5 volt output goes down to this decoupling capacitor and this other smooth capacitor. There's one other oddity here. They've added an extra resistor across the 5 volt supply, presumably just when it's powered down. I have done this myself. It makes sure the power supply goes down, the voltage drops really quickly and ensures a nice smooth processor reset. The processor is interesting in its own right because it's a 4-bit processor. SinoWealth SH69P20C, one-time programmable, 1K memory, 4-bit microcontroller. So this thing is capable of internal clocks of, which they're using, of 2 MHz, 4 MHz or 6 MHz. I'll make a wild guess and say it's 2 MHz based on what it's done. It's probably what I'd have chosen. It makes it more stable using the lower frequency, particularly for something that I'm guessing this may be quite an old processor. After that, it's fundamentally the block diagram of the processor is that it's got 4 4-bit ports which account for the 16 pins that have I/O facility and then 2 power pins. That makes up the 18 pins. And it's just very standard. These pins also double up as reset and other options, the external oscillator. Things worthy of note. The reset pin is used. They've got a 330K from the positive. I could doodle this down actually. You know, I've got, where have I I scribbled this schematic out. Tell you what, let's walk over all the things first. So we've got the rectifier, we've got the smoothing here, we've got the regulator, brings it down to 5 volts, we've got the microcontroller, the reset circuit, and then we've got all these little 1K resistors here going out to the display and I've worked that out as well, and a transistor. The transistor and a couple of these 1K resistors are part of the circuitry that goes to the output to the antennas, if you could call them that. Here is the schematic, and I'm disappointed. I was hoping it was going to be really exciting. I was hoping they were going to be doing something like big capacitors or inductors. Let's zoom up on this a little bit. I thought there were going to be big capacitors or inductors to really snap current pulses out to these coils, or really high frequency to capacitively couple between them, but it's not that. So look at the schematic. We've got the AC and bridge rectifier here, there's the big smoothing capacitor and the coupling capacitor, the 7805 regulator, and that leaves a 17 volt rail, and the 17 volt rail comes from the, I've lost the other calculator, that's why I'm back to this one. The 12 volts AC coming in times 1.41 gives about 16.9 volts. And the reason the voltage is higher once you've smoothed it is because the AC signal is normally described, the 12 volts is the RMS value, it's the average value of the voltage, but the peak value is much higher than the average. And when you rectify it and you have a smoothing capacitor, it charges up to the peak value. There is quite a bit of ripple in this. I stuck headphones across the output, and it's got a swept frequency, but you can actually hear the mains ripple as well. So we've got the regulator, we've got the smoothing capacitor on the 5 volt side, the 100 nano decoupler, we've got the 3.3K resistor to make sure the 5 volt rail goes down, we've got the reset capacitor, which is 100 nano, charges up slowly at power up from the 330K and ensures the CPU does a proper reset. There is one more resistor that's just used to tie a pin. Which one is that? That's used to tie a pin from the positive rail, 15K, to pin D1, port D1. They've used a resistor for that. I could just put a resistor in it. It's been used to hold a pin in a known state. I'm not quite sure. Maybe it's just sometimes on the microcontrollers the pins can be pulled up high or low internally, but you can't really leave them floating, and it may just be that one doesn't have that facility to pull it high or low, and it has to be tied to a logic level, which it kind of doubles as an oscillator pin, which that would make sense then. They wouldn't want to load it with internal extra circuitry, so that would make sense to have that resistor. And it's got a value of 15K. Let's write that in, 15K. So that's just to nudge it up. We've got a fairly standard transistor here. It's a low-level signal transistor, a BC945 or C945. What does it say on the thing? It says just C945. And it's a standard NPN transistor. And here's the odd thing. So one of the antenna windings is connected to the positive plus 17 volt rail via a 1K resistor. And the other end is connected via a 1K resistor to the negative rail. And the capacitor just shunts between them. So technically speaking, there is going to be some modulation in those coils, but it's really small. The only way this could really couple onto the pipe with this arrangement is capacitively, although it gets quite complex, and this is perhaps the clever bit of the design, that they're getting a wee bit sort of mystical, and therefore it's quite hard to disprove it does anything in particular. You're going to have a capacitive element to the metal or to the liquid inside. If this was on a plastic pipe, you could theoretically, by having these and having an AC signal across them, you could theoretically couple some current into conductive water, and hard water tends to be fairly conductive. And by having two of them in the plastic pipe, you would then theoretically be coupling a bit of current through the water, but it's tiny. And even take into account that if these were capacitors coupling onto the pipe, then charging it via 1K resistor, and the way the transistor is being driven here, it's just tiny little pulses at a ramped frequency. And it's an audible frequency. If you do stick the headphones in, you get a very distinct sort of trilling noise, a sort of from the actual the swept frequency. And with a metal pipe, ultimately, if there was any capacitive coupling onto the metal pipe, then it would just short out through the copper pipe. if you use your imagination, you can invent ways this would work. I had to crack out the oscilloscope. I had to crack out the Keysight. Thank you, Keysight, for sending me an oscilloscope. Let's, that's fitting in all right. And here's the odd thing. Because if they'd actually got rid of this resistor here and they'd tied the emitter direct down to the negative rail, then when this transistor's turned on, it would shunt these. What's the best way to describe it? It would result in at the moment it turns on, you get a slight voltage fluctuation, but it would have created a much wider swing. Let me show you on the oscilloscope. That's the best way to actually show you that, the oscilloscope trace. It's hard to fit the oscilloscope right under the bench, and to be honest, I was faffing around for a while. These dips here are actually the mains frequency modulation. So this is a sample across the full sweep of what it does. So it doesn't actually do a massive frequency range. I worked it out by putting cursors on those points, zooming in and putting the cursors on the oscilloscope. It suggests that the frequency ranges from 1.64 kilohertz to 5.5 kilohertz. So that's the low frequency end sweeping up to the higher frequency 5.5 kilohertz, and then it resets, and it just continually does a ramp. Quite easy to do in software. The actual pulses, the transistor turning on, this down here is this 0 volt reference. If they'd had that resistor missing, so the transistor wasn't operating in open sort of emitter follower approach, these pulses, these spikes would have gone right down to the sort of 0 volt rail. It would have actually created a much sharper spike. But as it is, the 17 volts here, each of these divisions is 5 volts. It's only coming down about sort of halfway, so there's only a roughly 8 volt drop there. It's not really that huge, 8 or 9 volts. The pulses themselves are tiny, really. They're like 4 microseconds each, and that kind of hints that with a microcontroller, you have the clock frequency, and then it's divided by 4 to get the instructions frequency. And for 1 megahertz, that would result in 4 microseconds for one instruction cycle. But the lowest frequency that can run at is about 2 megahertz, which would suggest that each of these dips is literally 2 instructions. One changing the state of the bit, the output bit, and then no operation, or maybe the next instruction then cancelling that, and it takes the time it takes to process that instruction is the time it takes to turn the transistor back off again. But it's just these tiny little spikes that are nothing compared to the rest. It's almost just, I don't know. It's very strange. So that's it. It basically, it does modulate the output. So you can't say, well, there's nothing in the output. It does have something in the output. And it's sweeping a frequency, so that ticks the box for the tuning to whatever the frequency of the contaminants in the water is. And that just leaves you to make the decision then, whether you think this is real or not, based on that circuitry, because it really is very, very simplistic. My own impression is that I would not waste my money on one of these personally, because I don't think it's real. But the only way you could prove that, and this is what these things tend to rely on, is to actually put it in a house and then saw the pipe in half and see if it had furred up. I remember when these things first came out, and they use the same pictures for the magnetic water softeners. They show a worst example of pipe that we core through it, and then all the crust, and then they say before and after, and it's a lovely clean coppery piece of pipe with no contamination. So that's what you'd expect to see if it did work, and you had an installation of this running for many decades, long enough to actually fur a pipe up. You'd expect to see this on one side and lovely clean pipe in the other, if it worked. Tricky. They also have a little cop-out saying that your kettle will still fur up because the pipe has water flowing through it, but the kettle, all the stuff is trapped in the kettle, and therefore it can't go anywhere, and that's why it tends to precipitate there. And then lots and lots of testimonials saying, I put this in and you can immediately taste the difference in the water before and afterwards, and no more spots in the shower and things like that. And you're thinking, have these been written by the people, or are they just people who have installed this and they're just got that lovely warm feeling when you've installed a device? But there we have it. My guess is, the LEDs. I didn't draw the LEDs in this because there wasn't a huge amount. It was going to be really cluttered. There are 7 pins. There are 12 LEDs. One pin, the one with the black lead, is the common, and it alternates between positive and negative. So it goes positive for one set and then runs through the channels, and then it goes negative and runs through the channels in that other set. That's how they've very simply multiplexed 12 LEDs onto 7 pins. Much of the time, there must have been a bit of time trying to work out, because the LEDs are not in order. It must have been a wee bit of effort to actually work that out in paper and write the code. But I would guess to actually get them to run the correct sequence. My guess for the software itself is that it's got a routine that does one sweep, one frequency sweep on the output. And the main routine, the software will have 12 steps, basically one for each LED, and it'll light the first LED, and then it'll call the sweep routine X number of times as a delay, then it will put the first LED out, light the second one, then it will call the sweep routine for X number of times and come back, and that's how it gets that chasing along while it's also doing the swept frequency on the output. So there we have it. I'll let you decide if these coils could capacitively couple. I mean, technically speaking, yes, it can induce current into the pipe, copper pipe, or if it was plastic pipe, it could induce current into the water, but not much current. But then, who knows, maybe it doesn't take much current to change the state of the water. This is what they rely on. So I can't specifically say, no, it doesn't work. But I can say that the output circuitry was less than I was expecting. Interesting. The microcontroller's interesting. It does make me think this might be quite an old design. And, well, if it works, don't mess with it, is what they say, and that's a good thing to live by. They could possibly use, I suppose ultimately the only incentive to change the microcontroller would be if it went obsolete, or maybe it is a standard microcontroller still. Interesting. Certainly worth taking a bit. So thanks to Mark for sending that. It was certainly fun to take to bits and have a little reverse engineer and see what it actually does in the output.